So the next thing we want to go over are some of the parameters for the normal curve that you do need to be familiar with. You need to commit what I'm about to share with you to memory so that at sort of a drop of a hat I can ask you some of these attributes of the normal curve, and you should be able to basically regurgitate these back to me. It's very important that you know this. So when we talk about the normal curve, we're talking about the standard normal distribution, or the bell curve. That's the terminology we use when we talk about the normal curve. Standard normal distribution. Our data are normally distributed. One of the key things that we will discuss is this idea of an empirical rule. And basically the empirical rule gives us a set of parameters for how our distribution is shaped and what percentage of values fall in certain areas of the distribution. So as you're looking at this graphic on your screen, basically those percentages there are the precise percentages that we can determine through calculus if we have a normal distribution based on the formulas for means and standard deviations that we just went through, what percentage of the distribution would fall into each of these little sections. Okay? So that center line that you see there and labeled below it is the mean. If we look at a standard normal distribution, one of the things you should notice about the mean is that basically they're mirror images on either side of the mean. Okay? So if I were to take and fold it in half, both sides are identical. Okay? And this is important to sort of grasp conceptually. Whatever you do on one side is the same on the other. And we'll talk about this more as we move through. But the first rule that we know about the empirical rule, and these are, let me say this, the empirical rule uses approximations. I've given you the precise percentages and the lines below, but the empirical rule is an approximation rule. So for instance, if we look at the values or the percentages between -1 standard deviations, which is the SD, and +1 standard deviations, we see that there are exactly 68.26% of the data or the values that fall between plus and minus 1 standard deviation. For the empirical rule, basically what we would say is that approximately 68% of the scores would fall between plus and minus 1 standard deviation. If we take that out then to 2 standard deviations, the empirical rule would tell us that approximately 95% of the values fall below or within plus or minus 2 standard deviations. We can then take that out to plus or minus 3 standard deviations, and the empirical rule would tell us that approximately 99% of the scores or values fall within plus or minus 3 standard deviations. Now I will tell you that generally speaking within social science, anything outside of plus or minus 2 standard deviations we consider weird, my technical term, weird scores. Anything outside of 3 standard deviations, plus or minus 3 standard deviations, is really weird. And again, those are my technical terms for our data that fall outside of that. So again, generally speaking, empirical rule, approximately 68% of our scores fall within 1 or -1 standard deviations. Approximately 95% fall within -2 and 2 standard deviations, and approximately 99% fall within -3 and +3 standard deviations. One last thing I just want you to note about this normal curve. This is when we know the distribution. If it's perfectly normal, we know these are the scores. However, we don't always know what our distribution shape is. And the question becomes then, if we violate normality, how bad is that on our data? Well, we have sort of this rule called the Chebyshev rule that looked at worst case scenarios. What's the most egregious violation that we can have of normalcy? And the Chebyshev rule basically tells us that it is theoretically possible that when we don't know the shape of the distribution, that at least very few cases will fall within plus or minus 1 standard deviation. On the other hand, by the time we get to plus or minus 2 standard deviations, worst case scenario is we have at least 75% of our sample that fall within plus or minus 2. And on to plus or minus 3 standard deviations, worst case scenario, we have at least 89%. Now, why is this important? You won't really use this a whole lot. I just want to bring this to your attention so that you realize that even if we don't know the shape of the distribution and our data violate normalcy, one thing we have discovered is that our statistical tests are fairly robust regarding violations of normality. The reason being is because we have this Chebyshev rule where we have discovered that this is the worst we can do. So why I say this? If you don't know the shape of your distribution, you can still be pretty well assured that almost 90% of the sample will fall within plus or minus 3 standard deviations. So without knowing the shape of the distribution, if I'm outside of plus or minus 3 standard deviations, regardless, you know it's still a pretty weird statistic within the sample, or a pretty weird value within the sample.